Good day everyone. Our project focused on developing a practical tool for calculating concrete mix proportion using Google Sheets. This presentation will outline our process, challenges, and solution in creating this calculator. Our initial step involved establishing the fundamental structure of our spreadsheet. We created columns for material, required volume per meter cube, total volume, material ratio, and material needed. This framework provides the foundation for our subsequent calculation. As you can see, column E lists the materials used: cement, sand, gravel, and water. Column F, labeled required volume per meter cube, contains a fixed value of 1. This represents the calculation base for 1 cubic meter of concrete. So this standardization simplifies the scaling process when dealing with large volume. Where column G, total volume, is where the user inputs the desired total volume of concrete in cubic meters. This input is crucial for determining the overall material.
Moving on to column H, we have the material ratio for this project. We utilize a 1:2:4 ratio, signifying 1 part cement, 2 parts sand, and 4 parts gravel. This specific ratio is commonly used in general construction and provides a good balance of strength and workability. It's important to understand that these ratios are proportional and do not represent absolute quantities. They serve as a guide for determining the relative amounts of each material in the mix. The water-cement ratio in our case is 0.5 is also included in this column, as its critical factor in concrete strength and workability.
Finally, column I, the material needed, houses the formulas that calculate the required quantities of each material. The formula for cement in cell I9 is equal to G9 times 500 times H9. This formula multiplies the total volume, or the G9, by the constant 500 kg of cement per cubic meter and then by the cement ratio, or the H9. For sand in cell I10, the formula is equal to G9 times 500 times H10 divided by the H9. This calculation is similar, but it adjusts the amount of sand based on its ratio relative to cement. The formula for gravel in cell I11 is equal to G9 times 500 times H11 divided by H9, again adjusting based on the gravel ratio. Lastly, the formula for water in cell I12 is equal to G9 times I9 times H12, which multiplies the total volume by the total cement needed and then by the water-cement ratio.
Through this process, we encountered several challenges, including accurately translating the mix ratios into spreadsheet formulas and correctly implementing cell referencing. However, we overcame these obstacles through careful planning and testing. The resulting calculator provides a user-friendly and efficient way to determine concrete mix proportion.
So this concludes our presentation. Thank you for watching.